All right, we are back for part 2 of our Lesson 1-1 notes. We just got done talking about all of our terms, which is equipment for the game of geometry. Now let's talk about the rules. The first postulate is the intersecting lines postulate, which says the intersection of two lines is a point. If we think about it, go ahead and sketch one line and sketch another so that they intersect. They definitely intersect at a place. Well, remember, a point represents a location. So if two lines intersect, then they form one point that we can name with any letter that we want. That is our first rule for geometry, the intersecting lines postulate. Sounds pretty easy. That one is easy to draw. I went ahead and gave you a picture for the second one because it is rather difficult to draw. The intersection of two planes is a line. This is called the intersecting planes postulate. And I would like you to notice that we have some solid pieces here and some dashed pieces here. What that represents is, if you'll notice on the purple plane, all of the edges of the purple plane are solid except for one side on the bottom here and then part of the right side. That's because we technically can't see it. It's behind the green plane. So it's kind of like looking through a piece of glass and seeing the border that way. So the dashed lines on a diagram represent something that is behind something else, whereas the solid lines represent something that we can see in front. So the intersecting planes postulate, when two planes intersect, they don't form a point like the lines do, they actually form a line. The line postulate says through any 2 points, there is exactly one line. Again, feel free to test that out. If I have point A and point B, if this postulate were wrong, this is saying I could create more than one line that has points A and B. Well, as it is, if I take my straight edge here and draw a straight line, well, there's a line that goes through points A and B. And again, I could name it line AB. But is there any possible way to draw another line? Some of you might be thinking about something like this. You say, well, it goes through A and B. I put the arrows on it so it goes on forever. But you may have forgotten that in order for it to be a line, it has to be a completely straight path. This green line that I have drawn is not a straight path, so it doesn't count. It turns out there is only one possibility, only one line that will go through points A and B. We have 2 more postulates. Here we have the plane postulate, which says through any 3 non-collinear points, there's exactly one plane. So if I draw 3 non-collinear points, remember I could draw a line through C and D, I could draw a line through D and E, but I can't draw one line that contains all of them. That's what makes them non-collinear. So through any 3 non-collinear points, there's exactly one plane. So I could draw exactly one plane that fits all of those in there. Some of you might be thinking, well, you could just draw a bigger parallelogram or a longer parallelogram, and those would be different planes. But that's not true, because technically a plane goes on forever. It's a flat surface that goes on forever. So if you think about the piece of paper that's in front of you that you're drawing on right now, that's a plane. So anything you could draw on that paper would be on the same plane. So through any 3 non-collinear points, there's exactly one plane containing them. Our last postulate says it's the flat plane postulate. If 2 points are in a plane, then the line containing them is also in the plane. So if I have a plane here, represented in this case again by a parallelogram, if I have 2 points on that plane, I can say those 2 points are coplanar. They're both on the plane. And if I draw a line through those 2 points, that line also lies on the plane. Again, because we can draw the points and the line on the same piece of paper, since that paper is one flat plane, then anything we can draw on that piece of paper is in the same plane. So it makes sense that if 2 points are on the plane, that any line or ray or segment containing them would also be on the plane. What I would like you to do without my help is to try the 7 examples that you have left on your paper. We will go over these examples, but I want you to give your best effort for all of them. I know that this is your first time seeing this information, but there are additional examples in the book as well as online at my.hrw.com. It's on your syllabus, my.hrw.com. Your username is rgeometry6 and your password is Falcon. Again, this is just if you need extra help. I think from what I've shown you today, you should be able to give your best effort for these 7 examples. They don't have to be right, I just would like you to try them. Please be careful with your notation. If you're naming a line, make sure you use 2 arrows. If you're naming an array, make sure you use 1 arrow and so forth. And we will go over these when I see you again in class next time.